Now that we love what operators can do for us, let's use the NuoDB operator to start a NuoDB SQL database. Inside this operator are all of the smarts needed to start a user configurable NuoDB database. We just need to ask for it. I have created this command, give me a NuoDB database. What this command will do is it will run the appropriate cr.yaml, which will provision the NuoDB database. On the screen to the right in the panel shows all of the parameters that are available to custom configure your database. I won't go through all of the details of each parameter, but as you can see, you can choose your storage to be persistent or ephemeral. You can enable the NuoDB Insights visual monitoring tool, which we'll talk more about in just a moment. And then you can also configure many other memory, storage, and CPU parameters. Let's go ahead and run the Give Me a NuoDB Database program. As soon as I ran the command, which runs the appropriate cr.yaml NuoDB database provisioning command, it signals to the operator to give me a database, and the database seems to jump right out of the operator. The operator is now busy taking all the necessary steps to properly provision a NuoDB SQL database. A NuoDB database is a collection of 3 different process types: an admin, responsible for creating a management domain across physical hosts that can support several logical databases; a storage manager, which we call an SM, which is responsible for making transactions durable to disk; and a transaction engine, which we call a TE, which is an in-memory database cache responsible for processing SQL transactions on behalf of a client application. The database will be active and available as soon as there are one of each process type running. Each process type has 1 pod. The TE has 1, the admin already has 2, it's on its way to starting 3, and an SM also has 1 pod running. Therefore, our database is now up and running and available. NuoDB also allows you to create a highly scalable and fault-tolerant system simply by configuring multiple of each process type. If any process should fail for any reason, it's okay. There are others of the same type to pick up the workload. The result, your applications are continuously available because the NuoDB database never goes down. While the operator completes the task of starting the NuoDB database, let's start NuoDB Insights, the NuoDB visual monitoring tool, and let's also start a sample SQL-based application using YCSB, the Yahoo Cloud Servicing Benchmark SQL Load Generator. We'll locate the NuoDB Insights pod. And click the URL that will start our NuoDB Insights web UI. As you can see, it's already running, registering that we have 1 TE process and 1 storage manager process. At the bottom of the screen, we see that we also have a YCSB load pod. There are no pods running, but let's simply start a SQL load application. That will soon start to generate SQL against our database. When the YCSB load pod runs, it first creates 10,000 rows by default in our database. It will then run many SQL connections against the database, simulating a read-write workload. If we go over to NuoDB Insights, we can start to monitor the activity against the database. If we click the SQL tab, we'll see that the rows are starting to insert approximately 400 per second. And Other YCSB connections have already started and are running updates against the database. We can start to see already in the lower center part of the screen where the aggregated transactions appear that NuoDB is processing currently between 200 and 400 SQL statements per second. As more and more YCSB connections are being made to the database, we can see that the transactions per second has quickly climbed up to about 4,000 SQL transactions per second. Using insights, we can also refresh the time period that we're reviewing, as well as the refresh rate. We're now viewing the database every 10 seconds in the last 5-minute interval, and we can see that the transactions per second is starting to stabilize around 4,000 transactions per second. Now that our database and visual monitor are both up and running and SQL statements are being processed, let's have some fun showing some of NuoDB's superpowers and benefits, starting with ease of scalability. As your applications require more or less SQL transactional throughput, NuoDB can dynamically be adjusted to meet those requirements at runtime. Unlike other databases, NuoDB's transactional and storage tiers scale independently of each other, a core tenet to NuoDB's container native properties. We can demonstrate this easily by adding more application pods, which generates an increased application workload, and then respond by scaling out the NuoDB transactional layer to meet the additional application demand. Let's get started. We'll add 2 more YCSB applications, and with several clicks, easily and dynamically increase the NuoDB transactional throughput to meet the new SQL demand. If we go back to NuoDB Insights, we'll start to notice there are new transaction engines that are starting to appear in the panels. We can see now that there are 3 transaction engines. The yellow line in the lower center aggregate transaction panel shows the number of transactions has increased from 1 to 3. As the additional YCSB applications that we just started add more SQL executions against the database, we can see how quickly NuoDB has scaled out to meet the transactional load. If we look at the last 5 minutes, again, we'll see a nice spike from our approximate 4,000 transactions per second to where we increased application load and NuoDB's ability to meet that load by adding 3 transactional engines. And we can see the transactions per second has leaped from about 4,000 transactions to about 9,000 transactions per second. That concludes the scale-out portion of the demo. Stay tuned for the next segment on resilience. To learn more about NuoDB, visit www.nuodb.com.